Right, guys, I hope you can see the screen and audio is clear. Yeah, so again, the same way, if you got any questions and all, keep posting. I'll be responding in between. So this idea, again, Google will help you. When is that first date of IIT mains and all. Right, so today we got electrostatics and current electricity, guys. Electrostatics and current electricity. So I'll try to, explain the concepts too, if possible, when and wherever it's possible for me. I'll try to explain you that. Electrostatics consists of three things here. Electrostatics generally, which is fields, electric field, electric potential, electric potential, and capacitances. Basically, electric capacitances as well as potential are treated as same, right? So sometimes they are given like separately in different books. So here, question number one. So today's topic is electrostatics. Can you guys see the screen and audio? Screen is clear and audio is clear. Right, done. On moving a charge of 20 coulomb, so question number one, charge Q is equal to 20 coulomb by a distance of 2 centimeters. 2 joules of work is done. Work done is how much? 2 joules. And the potential difference between the points, there's nothing to do with this 2 centimeters here because he is not mentioning any force. He said charge, he said work done. He's asking voltage difference are V1, V2. What is the change in potential? So work done is equal to charge into change in potential. Or we say potential is work done per unit charge. So using that, work done is Q into delta V, change in potential. Q is 20 and delta V we have to find. And work done is 2 joules. So delta V is equal to 2 by 20.1 volts, right? This is the relation of potential and work done. Next question, question number 2. This is a charged particle Q is placed at the center of O of a cube of length L. So there is a cube. This is how we try to draw the cube, guys. The charge Q at the center of the cube. Side of length L. Side of length L. Another same charge Q is placed at distance L. So from the center, if you keep a dotted line under charge Q, so this is L by 2, inside is L by 2. Distance between them is L, no? So exactly from the center L. The electric flux through ABCD. Electric flux through ABCD. He's asking, this one is A, B, C, and D. What is the electric flux through ABCD? So how to do it, guys? So we have one charge inside, the other charge is outside. Electric flux is due to the net electric field lines going through it. Okay. So if you see the charge is small q, he's asking ABCD. I don't think. So basically, out of ABCD, due to small q, the flux is equal to, we have 6 sides. Due to small q, it will be equivalent to 6 sides. Due to small q, the electric flux will be equivalent to 6 sides, right? So how much is it? Total, it will be q by epsilon naught, which is 6 times flux through ABCD, right? So due to each phase, it is equal, right? Because it is at the center. So flux through ABCD is equal to q by 6 epsilon naught. That is the due to small q. But due to the q outside, so if you see, if I draw the free body diagram kind of a thing, charge q is here. So electric field lines will be going through this like this side. So you see through the sides, it will go like this. So how to solve this? This is plane area. So I can try it in a different way. So this is q by 6 epsilon naught, right? Keep it aside. Now imagine another cube here, another cube here. Okay. So due to this cube, how much will be going through this ABCD? This is GF. Are you able to understand till here? Again, don't tell at the end, I am not able to understand. Okay. So if you have anything, just let me know now. So what I'm trying to do, due to inside charge, we got it. 6 by q by 6 not easy. Due to the charge outside, there are different ways in which we can find what I am trying to do. So due to Q, the charge flux going through this side will be Q by 6 epsilon naught. Just like this, will be Q by 6 epsilon naught. So whatever Q by 6 epsilon naught enters inside it, that has to come through these 4 and also this fifth one, 5 sides. Agreed or not? So this flux will be less than Q by 6 epsilon naught. So what is the sum of Q by 6 and Q by 6? Hello? Are you able to understand what I'm trying to tell? I'll try to redraw it again. Concentrate here, guys. Cube is this way. Good question. I'm trying to solve it logically. This is charge cube. Due to inside charge, the flux through this is Q by 6 epsilon naught, right? Due to the outside charge, the flux entering inside, that is the flux entering here. Okay. This will be Q by 6 epsilon naught. But this flux has to leave through this, and these 4 sides. So this Q by 6 epsilon naught will be leaving through this. So this should be X. Let this 6X. So X, this will be X, this is X, and this is Y. So I can say 4 sides, it is 4X plus Y is Q by 6 epsilon naught. Are you able to understand? Yes or no? Very logical question. So I'm trying to. Yes or no? You can just type yes, sir. Raghav. Are you able to understand me? Or I'm not getting the chats? Right, Shivangi. Please explain again. Okay, last thing what you told, I can't understand. Okay. So be clear about this again. I'm trying to solve it again. Oh shit. It's gone or what? Just a minute. Yes, this is gone. This is clear now. So the question is, there is one cube, guys. At the center, there is charge Q. What is the flux through this side ABCD? What is the flux through ABCD? This is there in NCERT textbook. You guys can tell easily. So due to symmetry, the flux is Q by 6 epsilon naught. No issues. Now what he has done from the center at a distance of L. So this is L by 2 inside, L by 2 outside. Under charge Q is kept. Under charge Q is kept or not? He's asking what is the net flux through ABCD due to Q. Suppose due to Q, these are the electric field lines coming out of it due to Q, right? Due to the outside Q also there are electric field lines or not? Cutting this, he's asking the flux due to both. So this yellow one is this one. We got it Q by 6 epsilon. We want the green one now. Charge due to the external. So what I'm doing is, I am extending the cube. Okay. So if I complete the cube, another cube, blue color cube. Okay. So if I complete this blue cube, what is the flux through this phase? So again, the same concept, flux through this, the green flux through this is equal to 6 q by 6 epsilon naught. Are you able to understand now? Right. Wonderful. So these green lines are not just coming through ABCD, they're also coming out through other phases. No, they're also coming through other phases. This is a good question actually. So other phases, let the other phases be these A, B, C, D. Then to the sides again. E, F, G, H. So these four phases, A, B, C, D, D, C, E, F, D, C, E, F, then this one, E, F, G, H, the bottom one, all are symmetrical for Q. All these side faces are symmetrical to Q. So what I'm assuming, the flux through this is X. The flux through ABCD is X. The flux through this bottom one is X. The flux through the back one is X. Because all four are symmetrical. Have you understood that? Due to this charge, the flux through this, and this. All are X's. And this one is different, so Y. So are you able to understand that? Okay. So now what I can say, when the charge is outside, so what we can say, the net flux entering the cube is equal to net flux leaving the cube. So I can say, what is the flux entering the cube? Q by 6 epsilon naught, which is 4 times X plus Y. 4 times X plus Y. Hope clear? Okay. Now, from this, can I say X is less than Q by epsilon 6 epsilon naught? X is less than Q by 6 epsilon naught. Now, so net flux, I'm just asking you to calculate the value. So what is the net flux? Q by 6 epsilon naught plus X. Q by 6 epsilon is due to this, and X is due to this. Are you able to understand? Net flux through ABCD is Q by 6 epsilon naught plus X. Now, what is Q by 6 plus Q by 6? Q by 6 epsilon naught plus Q by 6 epsilon naught is Q by 3 epsilon naught, right? So this will be less than Q by 3 epsilon naught. Because X is less than Q by 6 epsilon naught, this will be, if I compare these two equations, this will be less than Q by 3 epsilon naught. So far, is it clear, everyone? Raghav, Vatsalya, Shivagamati, Akshini, wonderful. So far, you understood. Now see the test. So among the options, if you see, among the available options, if you see, one is 0, wrong answer, right? Other is Q by 2 pi epsilon naught, which is more than 3. So there won't be L. I don't know why he has put that L and all. Q by epsilon only. No? Electric flux through ABCD is Q by 6 and this. So now the next one is D. So D is wrong because this is less than 6 by Q by 3 epsilon naught. D is also wrong. So option should be A, but option should be Q by, I'm just approximating, I'm not sure. So Q by 4 epsilon naught. So among the options, we are getting this Q by 4 epsilon naught. But this pi L should not be there because it is flux, electric flux through ABCD. So there won't be any L and all in it. So maybe some printing mistake and stuff. These are the options not there, but we get this. Are you able to understand? Not clear. Huh? You want me to zoom in? Just a minute. Clear now? So we get option A. That is also corrected, Q by 4 epsilon naught. The next one, if there are n capacitors in parallel connected to V voltage source, the energy of stored in equal to. So third one, there are n capacitors. They're in parallel. So there are n capacitors in parallel. In सबका voltage जो है ना, This is V. This is the battery symbol. This is the capacitor symbol. Each is C. Voltage is V. What is the energy of one capacitor? Half CV square. How many we have? Total of N capacitors are here. So energy, total energy is equal to N times half CV square. This energy is stored in the complete capacitors. Is it clear? Hope you understood. Yeah, see if you can get the answer, Vishal, directly, that is good. If we don't have that, you can always do. See, first thing what we people do to solve the question quickly is units and dimensions. So if the formulas are 4 different formulas, so you can see the dimensions. What happens? The 4 might be different or 2 are same. Then you have to solve it fully, Akshini. If q by 5 epsilon is given, no other go. So yeah, you have to solve it fully. I don't think they'll ask you that because for plane areas, you can't do it. Fine. If you have a curved area, we have this formula, no? Q by 2 epsilon into 1 minus cos theta, where plane angle is given. Gauss law. Now, if a charge Q is placed at the center of a line joining two equal charges Q, such that the system is in equilibrium, the charge of value of small q is. Charge Q is placed, so there are two charges. Question number 4. There are two charges Q and the other one is Q. So under small q is kept such that it is under equilibrium. So obviously it should be at the center because these two are symmetric. If they are Q1, Q2, it won't be center. If the total length is 2L, this is L and L. Am I right? That is simple guess. Now another guess, there should be an opposite sign because Q and Q will repel. So what is the repulsion force? K, Q into Q, Q square by R square. R square is how much? L plus L, 2L. So 2L square. This is the force of repulsion due to Q on this Q. This is F1. And force, now small q has to attract, no, or else it will fly away. If it has to be equilibrium, force F2 should be this way, which is equal to K QQ by L square. They have to attract, so small q is minus of, so small q is negative of Q. Capital Q is positive, this will be negative. If capital Q is negative, small q will be positive. So negative of small capital Q. Now I have to equate both. So KQ square by 4L square is KQQ by L square. So KQ square 1Q and L square gets cancelled. So K is minus Q by 4. Value, I'm substituting the value. But with sign Q is equal to how much? Minus Q by 4. For the system to be under equilibrium. Clear, bacho? Let me see. Anyone understood? Right. Now, if they ask you what is the potential energy, if the energy of the system is, this is small q is how much? Minus Q by 4. We have 3 charges, 1, 2, 3. So we have 3 interactions, 1 and 2 interaction, 2 and 3 interaction, 1 and 3 interaction. So potential energy is K into Q into small q by L. Again, this is also 2 and 3 is also same. So into 2 times plus K into Q by 2L. This is the energy of the system. So K capital Q, small q is how much? Minus Q by 4 by L into 2 plus KQ square by 2L. 1, 2 gets cancelled. So it is minus KQ square by 2L plus KQ square by 2L. We are getting how much? 0. So what is the potential energy of the system? 0. So interaction of these two is cancelled by interaction of Q and Q. This is the potential energy of the system, guys. Hope you understood this. There's extra information I'm giving you how to find out the interaction. Similarly, if we have a triangle of charges. Now, how much is a small q? In this case, force due to this is F, force due to this is F. If this is 60 degrees, this will be F root 3 because root of f square plus 2f square cos 60, 1 by 2, so f root 3. So resultant should be this direction, which is f root 3 due to small q. So what is f value? Kq square by L square. This is L. Kq square by L square is equal to k q small q by this distance. This is x, so substitute that x. So x you know about in terms of L, right? So this is L cos 30, 1/3 of it. So x is equal to L cos 30. This is 30 degrees. In this triangle, total is 60. This is 30 degrees. L cos 30. So cos 30, how much guys? Root 3 by 2. In that 1/3. 1:2 ratio, no? So 1/3. So it is L by 2 root 3. So x is equal to L by 2 root 3. K and Q gets cancelled. 1 L gets cancelled. You'll get the answer. X square. Are you able to understand? So we'll get the small q value. This is extra information. If it is triangle charges, if they are of square, they are square. We have 3 interactions. Q, Q, Q. Due to this, and repulsion due to this. People will forget this charge. No, all 3, F1, F1, F2. So we'll get the resultant. That should be cancelled by this Q dash. That resultant should be cancelled by this Q dash. Right? Wonderful. Good, good. So next question, I'll try to maximize this. So this is minus Q by 4. I'm trying to even brush up the areas around it. Maybe further more questions. So next, capacitance in farad of a spherical conductor with radius 1 meter. So what is the capacitance of a spherical conductor? So this is the formula here. 5th question. For a capacitance, if they are parallel plate capacitors, C is equal to epsilon naught A by D. For a single capacitor, so what is the capacitance? 4 pi epsilon naught. 4 pi epsilon naught R. R is the radius. If you have 2 capacitors, R1, R2, in this case, 4 pi epsilon naught R1, R2 by R2 minus R1. 4 pi epsilon naught R1, R2 by, so if we have 2 spherical capacitors, R1, R2, C equivalent is between these two. So we have capacitance between 1 and 2. We have capacitance between 2 and infinity. So there are 2 capacitors actually. The first one, C1, is 4 pi epsilon naught R1, R2 by R2 minus R1. The C2, which is the outside capacitance, is 4 pi epsilon naught R2. Because the outside radii will be infinity. So this becomes infinity, R1 will become 2. These two gets cancelled, we'll get R1, R2. Right? So capacitance of a isolated sphere is 4 pi epsilon naught R. Remember this. Already prepared for +2. So again, you have to remember this. So he said radius is 1. So 4 pi into epsilon naught. 4 pi epsilon naught is Sida, we can write 4 pi epsilon naught R. This is 1 by 4 pi epsilon is 9 into 10 power 9. So this will be 1 by 9 into 10 power 9. Radius is 1. So 1 by 9 into 10 power minus 9. This is 1.1 into 10 power minus 10. 1.9 into 10 power minus 10. So 10 power 9 goes to the numerator, 10 power minus 9. 1 by 9 is 0.11. So what I'll do, I'll write 1.1 into 10 power minus 10. That's 5th one. If you need it, take screenshot, guys. Don't hesitate and all. Take screenshots. Today, people are being less interactive. I'm not getting much responses. Why? Didn't have enough food? Janaki Raman, Vatsalya, Abhinav, Achyut, Akshini, BNS Kumar, Charan Karthik, Jagannath, Kavya, Niveda. What happened? So others are responding, Shivagomati. So you're not listening to the class and all. So you have to respond back. Yes or no. Speak out. No one is knowing your message. You can even keep it to me and message, sir, yes, sir, or no. So if you have any got, let me know. Yeah. So even S will work. If there's no sir also, it's fine. I just want to know whether you understood or not. The next one. If the electric flux entering and leaving an enclosed surface is Q1, Q2, the electric charge inside the surface will be, what is the electric charge inside the surface? So charge enclosed by epsilon naught is the net flux. So question number 6, again Gauss law. Question number is entering and phi 2 is phi 2 is entering, phi 1 is leaving. So what is the net flux? Phi 2 minus phi 1 is equal to charge enclosed by epsilon naught. So charge enclosed is epsilon naught into phi 2 minus phi 1. Agreed? So sixth one is option A. So entering and leaving. Entering is phi 1, exiting is phi 2. Okay. So entering is phi 1. That means negative charge Q1 will be more. So if it should be phi 2 minus phi 1 only. He gave this is Q phi 1, this is phi 2. But so net charge and outside is more, it will be positive, right? So net out. So we have to find out phi 2 minus phi 1 only, not phi 1 minus phi 2. So outside, phi out minus phi in. Okay, this is how you should remember, phi out minus phi in. So the sixth question. If you write reverse, it will be negative charge. Which question number? Achyut. 5. Spherical conductor, if there is a sphere, if the radius is r, uska capacitance is given by 4 pi epsilon naught r. This is the formula for spherical capacitor. So 1 by 4 pi epsilon naught value is 9 into 10 power 9. So what I am doing, so 4 pi epsilon naught is 1 by 9 into 10 power 9 and radius is 1 meter. He gave 1 meter. So 10 power 9 goes to the numerator, 10 power minus 9 by 9. 1 by 9 is 0.11 into 10 power minus 9. It is 1.1 into 10 power minus 10 farad. If you understood. Seventh one. A sheet of aluminum foil of negligible thickness introduced between plates of a capacitor. The capacitance of the capacitor. What happens to the capacitor? So negligible thickness. Here it is negligible thickness. So basically what happens when we have a capacitor, the distance is L. So capacitance is epsilon A by D. If we have a metal block of thickness T, then capacitance becomes epsilon A by D minus T. If it is a block of dielectric constant K, C equivalent will be epsilon A by D minus K, and it is they are in series, no? So C1, C2 by, so 1 by C equivalent is D minus T by epsilon naught A plus T by K epsilon naught A. This is the C equivalent when you introduce a slab of thickness T and dielectric constant K. Now when you put a metal, this K will become infinity, no? This becomes 0. So, but in this case, T also is 0 because negligible thickness. So what is that 1 by C equivalent? D minus 0 by epsilon naught A plus 0 because it is T by 0, T by infinity. So this becomes 0. So C equivalent still remains same, epsilon naught A by D. When you are introducing a thin slab, metal slab, C remains same. C is equal to constant. It doesn't change. If it is of dielectric constant K, then you have to use this formula. 1 by C, remember this, is equal to D minus T by epsilon naught A plus T by epsilon naught K epsilon naught A. This is the formula. This is C equivalent ka formula. Hope you are able to understand this. Thank you. Yeah. Remains unanswered. Guys, I just want a question here. I'm trying to do more questions in the session. So you know, already did around 7 questions. So we'll be doing this 3 more and then we might go to current electricity. So I'm trying to cover 10 to 20 questions somewhere in between during the session. Do you want me to go and also recap the topics around it? Do you want me to go slow or is this speed fine? So how many questions would be fine for you? I just want your feedback. You can just send the number, rough number of questions. per session. As 1 hour, or you might push it a little more. The speed is fine. Okay, so wonderful. Because I want you to get this confidence that you can also solve more questions in exam in that 1 hour. That is when I'm trying to do more. Good. So wonderful. Thank you. Thank you. And also talk to your friends, whoever is missing the sessions or not attending, your classmates and all. There is something which is given being free and of this quality. It is better if they attend. Agar something good happens to them in future, they will thank you. Due to you, because of you, I got these few questions right, man. So please do try to spread this word among your friends so that they will know and they can also join. Right. So remind them, ask them to attend the session. It's really great. These many of you are attending is not a small thing. I'm trying my best Vignesh concept also, but the time again. So we have 1 hour for 4 chapters. Now you imagine we are getting 15 minutes for one chapter, and we have 5, 6, or 10 concepts per chapter. So do you think I can revise the so what I'm trying to do? So while solving the question, I'm trying to recap the concept behind it. Right? Yeah, you have to message here. That is the only option now we got. You can just message here whatever question you want. If you want, after the session is done, right, 7:45, I can stay for a few more time. If you got more doubts, you want me to go back and discuss and all, we can do that. So first 1 hour we'll do the generic session. Maybe 15 minutes or sometime I'll wait. You'll have if you got questions, you can ask again. That should be good, right? So others can leave and yeah. There's nothing like important, Shivagomati. As far as I have been teaching, no, we never know. People will say this is important, this is not. No, nothing like that. All are equally important. No one knows. We God who got it. Other than that, even the paper setter at this point, he doesn't know what question is going to come in future. Right? So better to recap all is what I suggest. Next one, a thin spherical sphere shell of radius r has a charge q. Another charge q is placed at the center of the shell. The electrostatic potential at a point P at r/2 from the center of the shell. Okay. Inside is small q, on the sphere is capital Q. Negative charge. Thin spherical shell of radius r has a charge q. Under q is placed at the center. Okay. So, eighth one. There is a sphere of radius r. There is a charge q at the center. Charge on the outer sphere is small q. Here they are asking at a point P. So, the distance of r/2. Now, so how is it going to be done? Due to a spherical shell, due to the shell, potential at P due to shell is equal to K Q by small r. You know this? Potential inside the shell due to the shell is K Q by r. Potential at P, point P, due to the charge Q is equal to K capital Q by distance. We have to treat it as a point charge. This will be r/2. So 2kq by small capital R. So V total at P is equal to sum of these two, kq by r plus 2kq by r. Kq by r plus 2kq by r. If I ask you what is the potential at outside point, there's outside point, some A. What is the potential here? The distance is 2r. The radius is 2r. So radius 2r and this point is outside. So even the sphere becomes a point charge. So this will be kq by capital R plus 2r and kq by 2r. This is a potential at A. So due to thin shell as well as this, both behave like a point charge. It is k into q plus q by 2 capital R. This is for outside charge. This is for an inside charge. So let us see is that option is there. 2 capital Q. Yeah, this one. Option C. There is no minus sign. There is no minus sign. So I will ask you a difficult question, little difficult question in this. You'll be doing good if that type of question is asked. So here you have to concentrate. Now, instead of a thin shell, what I am trying to do, I am taking thick shell. There is a thick shell. Inner radius is capital R. Outer radius is 2 capital R. This is conductor. What is this? Conductor. There is a point charge at the center, capital Q. And I have given small q to the sphere. This is completely solid. This is the concept here. Now you have to learn. Small charge q. what is the potential at similarly, there's a point P, the distance R by 2. There is another point, let it be point A. There is another point B outside at a distance of 3R. Give a try. I'm giving you first time, I'm giving you a question, asking you to try. Potential at A and potential at B. This is thick shell, thick conducting shell. It is not thin, it is thick conducting shell. This thick conducting shell. I hope you understood the question at least. Just 2 minutes. Give a try. I don't mind you getting wrong answer. I'm completely okay. Has anyone got any answers? So Vishal Kumar, I would suggest, I already guided you. So what I told you is before the session, Vishal, I would expect you to study the concept because you got the schedule with you. So you have this particular chapter which is going to be discussed with you. So it is your job to revise that concepts. This is what I was suggesting, how to prepare for the session. So in the afternoon hour, after lunch, so what you should do, I'll share the screen and yeah. So after lunch, recap the concepts of electrostatics current. Suppose today is electrostatics current electricity. Recap the concepts of that particular chapter. Then come to the session. Then see how you are applying the concepts in the session. Once the session is done, that 1 hour, 1 hour 15, whatever time, after that, you have to do the questions in the same chapters of previous questions or under textbook. You cannot expect everything to be done in this 1 hour. So 15 minutes, I can write the formulas. What I'm trying to do, those formulas according to the question I'm discussing. So I'm not listing out all the formulas. In each question, I'm trying to give you another formula relevant to that question. That is what I'm trying to do. So as a student, I would expect you to do the revision part and come to the class. And on the next day, in the morning session, tomorrow morning, you can work on the questions from electrostatics and current electricity. And afternoon, again, tomorrow schedule you have the chapter there, topic there. Prepare for that chapter. That is what I suggested. It is better if you follow that. Right. So let us do this question now. Right. So here, what happens in shells? So what happens in shells? The charge flows out. So when I put this charge Q at the center, this is Q. This due to capital Q, there is a minus Q induced here. Due to capital Q, there is a minus Q induced here. And this minus Q, this outer complete sphere should be neutral, right? So when this minus Q comes here, and also this small q also flies out. For a solid conducting sphere, charge will always try to fly out. So go out, it will come here. And due to this minus q, this will be plus q. So again, see the total charge is small q only because it is a conductor. The total charge is still small q on the conductor, capital Q on this. Now if I take a point A, potential at A is equal to, due to capital Q, this is R by 2, no? Due to capital Q, so KQ by R by 2. Due to minus Q, this is minus KQ by R because negative charge due to this minus Q. And due to the outside charge, this is called induction. Due to outside charge, K into capital Q plus small q by 2R. Because this behaves like a thin shell of negative charge. The outside one behaves like a thin charge of positive charge. So we have two shells. One shell of minus Q, other shell of Q plus Q. So this is the potential at A. Now potential at B, outside charge, potential at B, all behaves like a small, point charge. So KQ by 3R, due to minus Q also minus KQ by 3R, due to Q plus Q also plus K into Q plus Q by 3R. So when you take an outside point, this minus KQ by 3R plus KQ by 3R cancels. You get KQ by 3R plus K small q by 3R. So these two gets cancelled. So for an outside charge, this KQ by 3R gets cancelled and we have this. But for inside charge, this really matters. This is one of the point. They can ask you IIT mains or advanced also. They can ask you this type of questions. Take a screenshot. This is called induction, charging due to induction. Right? Take screenshot, guys. Still not clearly visible. So take a screenshot. By the way, this question is not there. I made this question. So I made this question. So it is not there. You have to go with this. Okay. They have given a simple question. I tried to make it 2 to 3 questions, little difficult ones. Take screenshot, guys. So while reading the question, I'll go to the sheet, expand the sheet, read out the question. While solving, I'll come here and solve it. Yeah, so I'm showing it again. No, the next one. So this is done. This is being done. I hope you can see this. So again, this is a capacity he gave. Q is equal to CV. So V is Q by C, right? This is the potential into charge, Q square by C. So charge he gave, capacitance he gave. Question number 9. So half Q square by C. V is this one. So energy for 9th question is half Q square by C. So charge is given, capacitance is given. Just substitute in the formula. So we have a few more questions. So shall we start this current? So we've done potential, we have done electric flux, field, and we have done energy. So different types of questions we did. We'll go to current electricity. What I would suggest, take screenshots of this. So till here we have done. Take this question from here, screenshot. Or if you want, I'll keep it like this. Take the screenshot of this. You're taking the screenshot. 10th question also, if you want. This is a screenshot of this 10th question. Okay. Next one. If we get time, we'll come back and solve. If you don't have time, it's your job to go. So tomorrow's homework for the morning session is doing these questions. This is done. If you do this, your topic is done. This is the best you can do. Don't expect I'll do PhD in electrostatics. No. You have 1 day for these chapters. So 5 hours for each chapter on and whole. Yeah. Take the key also. It will help you. Right? Hope you have taken screenshot. So explanations if you want. We have done till here. If you want, you can take it. Then 11th one, say. Because once you have solved, if you got questions, what I see, this 13th one, I guess, is the one like the one I was explaining, I guess, square and all. So you have to find out F1, F2, F3, then resultant is balanced by this Q. Same question. Right? Take a screenshot here. Done. The last one. If I got time, I'll come back and do it, so don't worry. But you got work for tomorrow. Tomorrow morning session, you would have got work. Do this remaining questions. 10 I have done, we have 28, 18 more questions. Give a try and then solve. Don't do it directly. See that, don't do it directly. So we have 21 here. Let us see how many we can do here. Right. Question number 1 to 10. Okay, we'll do that. take this 1 to 10. Okay, solution also will show 1 to 10. Right? Okay. So let us start current electricity questions. You want me to do it here, then space is not right. That is the only problem. Space is not sufficient. So the length of a wire of a potentiometer, or I can toggle between this and no notes. The length of a wire of a potentiometer is 100 centimeters. Normally, potentiometer is 100. And EMF of its standard cell is E volts. See the difficult question. Difficult means little length. It is employed to measure the EMF of a battery whose internal resistance smaller is 0.1. The balancing point obtained at L is 30 for the positive end, then the EMF of the battery. So we have battery as well as internal resistance, guys, right? Did he give any I and all? Okay, so 30, let us draw this potentiometer diagram. So what actually happens, there is a primary battery. Let this be E naught. Now we have a wire here. Okay, we have 100 centimeters. So potential, we have lambda gradient is E naught by 100, right? There is volt per meter or centimeter. Your wish, 100 centimeters or centimeter. Now what we are doing, we are taking another battery of EMF E and internal resistance smaller and trying to find out the balancing length. Try to find out the balancing length. EMF standard cell is E. Oh, this is E then. Z dash. Balancing length L is equal to 30 centimeters from the positive end, the EMF of the battery. Is asking the EMF of the battery. So in this case, when balancing length is coming right, there is no current here. I is equal to 0. So what is the voltage of this? 30 by 100 into E. The voltage of this part is 30 into 100 into E. If you are seeing the voltage per unit length. This 0.5 is the internal resistance of this battery, no? I is the current in the potentiometer wire. So it doesn't matter on that 30 by 100. We are getting 30 by 100. This is the answer. So option D. At balancing length. What is meant by balancing length, man? The galvanometer here shows a reading of 0. You know what is balancing length? You remember the potentiometer concept. So in potentiometer, we have a wire. We have a battery here. This is the primary battery, right? So if this is voltage E, if the length of this is L, so lambda voltage per unit length is E by L, right? I have a battery here whose voltage is E dash, whose resistance is R, which is 0.5 ohms he gave. Now you are using a galvanometer and finding the balancing length, which is how much? 30 centimeters. And this capital L is given as 100 centimeters, right? So what is the voltage between these points A and B? So voltage between A and B is 30 by 100 times of E. That is the voltage. Now the current here is 0. At balancing length, I is equal to 0. That means there is no drop here. So the total voltage is E dash. So this is nothing but E dash. Right? They might have given wrong. So please do check it. I hope you understood. You can take screenshot. I can do this way. I guess I can maximize this and work here and minimize this. Right? Done. Yes, sir. Got it. Wonderful. No, it is not option C. If that R is 0.5 is of the standard cell, if R, here current I is 0. So if you see at balancing length, agar if it is option C, this 0.5 I, this 0.5 is the resistance of the battery E dash. I should be the current in E dash, no. Current in E dash is 0. He said it is employed to measure the EMF of a battery. So the one which you are measuring, the resistance of that is 0.5. This is 0.5, not the internal resistance of this. Okay. All right. Second question. 3-volt battery with negligible resistance is connected in a circuit as shown. The current I in the circuit. So if you see this 3 ohm are in series, though they it's triangle, this 3 and 3 are in series. So what is the sum of these two? 6. And this is in parallel with 3. So R equivalent is 3 into 6 by 6 plus 3. 18 by 9, which is 2. So R equivalent is 2. So what is the current I? I is equal to V by R, 3 by 2, 1.5 amperes. These two are in series, guys. So I comes here, it gets divided as I1 and I2. I2 goes this way. So I2 is coming and going. Is that clear? 1.5 amperes. The length of a given cylinder wire is increased by 100%. That means there is a length L, there is a cylinder, right? Now, given cylinder wire, area BA. Now what you have done, length got increased by how much? 100. That means it became 2L. What will happen to the area, guys? Area will become A by 2 because volume should remain constant. Volume is AL. Here volume is equal to 2L into A dash. So A dash is equal to how much? A by 2. Area becomes half. When you are pulling something, stretching something, area will decrease or not, right? So length is becoming 2L. Then what is said? That's it. Then the resistance. So initially R0 is equal to rho L by A. So R dash is rho into length is 2L, area is A by 2. So 4 rho L by A, which is 4R0. Resistance becomes 400. So it is got increased by how much? 300%. Resistance got increased by how much? 300%. If 400 is there, you should not mark 400. It got increased by 300%. Easy one. Let me see. Third question. Right. People got it right. This weightage of chapter is not constant in the history. What happens? Sometimes this particular chapter gets more, sometimes that particular chapter gets more. So what people think, okay, optics, there are like many questions are coming. Let us do optics. Optics is a lengthy chapter. If we take AC circuits or EM waves, less number of questions are there, small chapter. So it is not like something is big, something is important, something is not. So electrostatics, yeah, you'll get more questions, important, more questions. But electrostatics consists of electric field, potential, capacitors. So there is a lot more to learn in it. So in exam, I don't have any idea, ma'am. As when I gave, calculator was not allowed. I don't know the rules now. You have to check. So as soon as we get the mains, they'll give notification, no? In that notification, they will mention all. Is calculator is allowed or textbook is allowed and all. I don't think calculator will be allowed. So never thought of that even. Because people might bring different types of calculators and all, then everything will be ruined, no? So wherein they might have data and stuff. This is not allowed. The total current supplied to the circuit by the battery is, so here we have 3 ohms. If you have to draw it in a right way. So battery, 6 volts. Battery is getting connected to 1 2 ohm, another 6 ohm. These two is connected to 1.5 ohm. This 1.5 is going back to this, right? So this one is done, this one is done, and 3 is connected to battery directly. So 3, if you see, is connected to battery directly. Any doubts here, guys? Is it clear? So we have 6 and 2 parallel. 6 and 2, 6 into 2 by 6 plus 2, 8. 4s are, so 3 by 2, 1.5 ohm. So equivalent of these two is 1.5, 1.5. So we'll get this as how much? This will become 1.5 plus 1.5, 3 ohm. 3 and 3 are in parallel. Again, this is 3, this is 3. So 3 and 3 are parallel. So we'll get 1.5 ohm. So what is the current I through the battery? V by R. V is 6 by 1.5. 4 amperes. Is that clear, everyone? Yes, sir. Very clear. Wonderful. So how we draw this circuit is what matters. The resistance of series combination of two resistances is S. So two resistors R1, R2. So R1 plus R2 is equal to S. When they are joined in parallel, so R1, R2 by R1 plus R2 is equal to parallel. So he's saying this S is equal to N times P. Then the minimum possible value of N is, what is the minimum possible value of N? So we have to simplify this to R1, R2. So I'll write it, try somewhere here down. Where is a space for us to write? Yeah. So R1 plus R2 is equal to N times R1, R2 by R1 plus R2. So when we want things to be minimum, right, we take the equal cases, like if you have 3 ohms and 4 ohms, something like this. There are different values. When you take equal value, many questions, when you differentiate, we get them as equal. So R1, R2 both are variables here. So minimum you'll be getting as this, let us see, R1 plus R2 whole square is equal to M times R1, R2. So R1 square plus R2 square plus 2 R1, R2 is N times R1, R2. Right? So R1 square plus R2 square is N minus 2 R1, R2. N minus 2 R. So one case is N should be greater than 2 because or else it will become negative. So N should be greater than 2 first. Then we have R1, R2 both are variables. So you cannot say one is more, one is less. So one is infinity, other is 1. So the only possibility being is both are equal. Right? So because we have two variables and one equation, two variables. How can you solve it? It's just a boundary condition. So here the only possibility is they should be equal. So in that case, what is that we are getting? 2R square. So R1, R2 I am replacing as R1. 2R1 square is equal to N minus 2 into R2 I am replacing as R1. R1 square. N is equal to 2 plus 2, 4. So minimum is 2. It should be greater than 2. And that happens when both are equal. Other than that, we are not getting them as equal, right? So you'll get value more than this. Right? Because if you give a guess, one is 100 ohms, guys, other is 1 ohm. If you say parallel, R is approximately 1. If you say series, R is approximately 100. 101, I'm taking as 100. So we have 100 times. If you take 1 and 1,000, 1,000 times, 1 and 1 lakh, 1 lakh times, and N is becoming more. So what is the minimum value for N? When they are equal. So when both are equal, so 1 is less and 1 is more, we are getting very high number. We get less number when both the resistance R1 and R2 are same. And for that, we got N is equal to 4. That is the minimum value. This kind of trial and error we say, right? So I'm just asking you to do that. Have you copied it? Take the screenshot. See, to see it is simple, just conceptual, but you have to work on it. Let me see if I can do anything more. Kirchhoff's laws. This circuit, the 14th one, if you see, it is Wheatstone rich. It might look different, but it's Wheatstone. 10 by 5 is 2, 20 by 10 is 2. I can remove it. So 20 plus 10, 30 ohms. 5 plus 10, 15 ohms. What is the equivalent? 13 into 15 by 13 by 15. 3s are 10. So what is the equivalent? 10 ohms. So what is the current? 5 by 10, 1 by 2, 0.5 amperes. Question number 9. In the circuit, the galvanometer G shows 0. That means I2 is 0. If the batteries A and B have negligible internal resistance, they don't have internal resistance, the value of resistance R. So if this current is 0, that means voltage about these 2 points are same. No, then only current is 0. If this is 2 volts, this will be 2 volts. So 12 minus 2, the voltage between these 2 points is 10 volts. And what is the current? So what is the current, guys? I is equal to V by R, 10 by 500. Right? The same current goes into this because I2 is 0. So I1, I2 both are zeros. There is nothing going inside. So voltage about R is 2. So V is equal to IR. 2 is equal to I into R. What is I? 10 by 500 into R. Agreed? 2 5s are. R is equal to 100 ohms. He gave galvanometer G shows 0 reflection. So current in this is 0. Have more questions to do. There are many more. Very little good question. 18, 19, lengthy questions too, because 2018, I guess, advanced, it is not mains. We have paragraph question. It is difficult and advanced, very good question. We should go through this. So again, so here, Wheatstone balance, Wheatstone which concept, meter which 55 R, this is 20, this will be 80. So 55 by 20 is equal to R by 80 when it is balanced. So R is equal to 55 into 80 by 20, which is 4. So 220 ohms. Right? So it's time. So tell me any doubts in the questions I have done or any questions, guys? Can you take the screenshot again? Let us take screenshot of this. So till this one, first one, sheet 1. So whoever comes to the class, those people only will get this sheet. Others will get in the terms of screenshots. Right? Done. Take a keys also is done, no? Take the solutions also. So tomorrow's work is given, guys. Tomorrow till afternoon, you got plenty of work to do. If you are doing this, then do come and ask me. And I'm telling you, if you are doing this work, it is more than sufficient for you, for whatever we got in hand for us. Take this also. You are doing class discussion as well as you are doing homework. You are getting homework. So before the class, you know the schedule, do it. Suppose I'm ahead of schedule. So, next physics session will be whatever is there in the next week's one. And I guess Kal se everything will be set. Tomorrow it is maths, right? According to schedule, it will go like that. And the next math session physics session will be taken by maths sir, so that everything will be on track according to the schedule. Right, guys? Done till now? Yeah. This thermal effects, heat exchange and all, this also you can do, but not now. I don't think I've included, but take screenshot if possible. I'll only give till key. Thermal and chemical effects of current. It's like heat energy produced due to this. Power questions. If you do next session, if you want, I'll do questions from this heat and this and continue with other chapters. So I'll do a few more questions from this and then do magnetism. Next week it is magnetism. Okay. So I'll discuss questions in later. So next, if magnetic effects of current, and then we have magnetism, these two chapters. EMI AC, let us see how it goes. So yeah. So Raghav is Galaxy J2. Raghav is there to help you out. No doubt, sir. That's wonderful. So please do attend to the class, right? And regarding the preparation, I'm telling you again, right? So again, what you have to do, before the session, you got the schedule, prepare for that particular session, revise it, then attend the session. You'll understand why the teacher is applying this concept there, that formula here and all. Once the session is done, I'm giving you assignments. If that work is not there also, you have plenty of material. Like you can Google also, previous IIT questions will get that set. But year-wise you'll get, but not topic-wise. If you can get that collection of previous IIT mains questions, that will be wonderful. Okay. Okay, I will do it chapter-wise, Amma, not at the same time. I cannot do. Courtney, sir, like this show. Yeah, as we go on, every chapter I'll be showing. So if you want the complete assignment, attend the complete sessions. Okay. Right. So how was the session, guys? Are you able to, yeah, it is not complete. It is not, I would agree. We have to do more. But within the given time, this is the direction I can show you. This is the torchlight size, with night light I can show you. As you work more, you can see more light coming out there. What is the difference between 2004 or 2020? You mean the paper level? So it's like previously it was increasing, later on it was decreasing. The level, it is becoming easy because the people who are giving the JEE, I don't know, the quality of the students and all is decreasing day by day. So the paper is decreasing. So no, that is why I'm telling you, don't think it's very difficult and all. No, right? It is easy only. Do the basic and medium level questions. That is more than sufficient. Happily you can crack it. But you have to work hard. Sir, I attended 1 hour every day. Why am I not getting all India top 10? You won't get all India top 10. Right? So already you missed so much time. Around 2 years. In 2 years, now you realize you're really, you people have taken it seriously. That you have to continue, not just for this 1.5 hour or 1 hour, the whole day. So till the March or April, whenever we have this exam and next one, right? So till then, multiple mains we have, right? So even another chance is there. Please do work. Every day, 15 to 20 hours you have to work, including the class hour, you're working, reading, everything. Then you can end up in good colleges, maybe NITs, BITS and all. You understood? If you are like 1 hour I have attended, why am I not getting? You won't. People out there are doing hard work from school level, like 6th, 7th class, they are going foundation. So they're going to schools, evening times they go for foundation, or they joined a college where it is complete foundation, right? So please do that. Realize that. Don't compare ki main 1 hour kar raha hu, why am I not getting? You won't get. So you have to give your best. So only one thing should be there in your mind when you're going to your bed. Have I given my best today? If not, how I can do better on the second day? Do it. Okay, I could have reduced time on TV, games, or chit chatting with friends. Because you're at home, you waste so much time, right? We try to spend time on other stuff and all. Don't do that. So keep this in mind. If you want to end up in a good college where the life, it's not just the placement, guys, your lifestyle will be wonderful. Your lifestyle too will be wonderful if you end up in a good college, right? Amrita also, you have an exam, right? So that also you have to crack, so to prepare well. And we have other bits and many other exams. Even few give even ISC Bangalore exam. Yeah, any more questions? Thank you, Karthik. Thanks for your encouragement. Hope it's really interesting for you. Do the questions. Do the questions. Nishan Saura. Mass of block A is M and that of mass B is 2M. They are attached to ends of a spring and kept in horizontal surface. The spring is compressed by X and released. When the displacement of B by the time compression is X by 2, friction of A is 0.2 and friction on B is 0.1. Now, you haven't mentioned K and this one. How can you say they are moving or not? They are slipping or not? You haven't mentioned the K value, spring constant. And you want to make an empire. Nice one. Sure. So let me discuss this question first. Yeah. So if friction is not there, center of mass should be at rest. So you can see M1 X1 is equal to M2 X2. In that case, we can do. Now that X you are saying has become X by 2. Compressed by X, it has got X by 2. So this X by 2, the force F is being applied on both the blocks. One is 0.2, other is 0.1. So friction force is same, right? That is the maximum friction force. Let me see, Nishan. Can I copy this? There are two blocks, M and 2M. They are attached by the spring. So friction here is 0.2 is what you say. Friction here is 0.1. So the maximum F max is mu mg, 0.2 mg. And here also F max is 0.1 into 2 mg. So 0.2 mg. So frictional force is same on both sides. Spring constant is not mentioned. Initially, if this is the length, you have compressed it by how much? X. So this is X by 2. No, not X by 2. So the compression is X. Now it is becoming X by 2. Frictional force is same both sides. So spring will move both of them with same F, right? Because friction force is F, they'll come to stop at the same time. But their masses are different, right? So same force, their displacements will be different. So acceleration of this is F by M. Acceleration of this, oh sorry, am I sharing the screen? Are you able to see Nishant Saurav? Yeah. I hope you're understanding it, Saurav. Right. So F by M, F by 2M. So acceleration of this is small. If they are coming to rest at the same time, because again friction is same if they're coming. So what is the displacement? Y is equal to half AT square. So proportional to A. So let the displacement of this will be X1, this is X2. So from acceleration, I can tell this is F by 2M. So acceleration, I can tell X1 is equal to 2X2. X1 is equal to 2X2. So total displacement is X1 plus X2. It has moved X1, this has moved X2. So X1 plus X2 is X by 2. That is what he said. No, initially it is X, now X by 2. X1 plus X2 is X by 2. So X1 I am replacing 2X2. So 3X2 is X by 2 and X2 is X by 6. X1 is 2X2, which is 2X by 6 or X by 3. So mass M moves X by 3 and mass 2M moves X by 6. Nishant, what is the answer, Nishant Saurav? Was it right? Thank you. Thanks for that. So happy that sir ko checking ho gaya. Sir can do questions. Right. Good. So this is how you should solve. So one thing what we did, we found out the friction, they are equal. Then I found out the accelerations, they are not equal. So displacement is proportional to acceleration. So I assumed X1 and X2, compared X1, X2, X1 is 2X2, then solve it. Take screenshot if needed, Nishant. It's good, Nishant, if people should ask questions like this. So others should also do it, guys. If you got any questions, you can just bring them on board and ask. Thank you, guys. Thanks for your time. Wonderful session with you guys. So 4 more physics sessions to go. We'll see how it goes later. Okay. So thank you. Bye.